everyone, and I welcome you all in this class. And today we are going to start the third law of motion. In our previous class we have covered till the topic second law of motion, and today we will discuss how the third law of motion and few applications of the third law. Students, as we all know very well about the third law as comparison to the other two laws, that the third law of motion states that there is for every action there is an equal and opposite reaction. Students, the third law is a very common law of the nature, and this is a very practical law. Students, you can try this law, you can practically observe this law. Whenever you throw a ball on the wall, the ball gets bounced back. Whenever you put a ball on the first, whenever you throw a ball on the ground, the ball return back. What happens? We apply a action on the ball and ball get the reaction from the ground. Whenever we hit our hand on the ball, we always observe there is a force, there is a jerk on our hand, because whenever we apply a force on some bodies, we always get a reaction from that bodies. Then it states that for every action there is equal and opposite reaction. Students, in this law, in our third law, whenever we study, these two forces, action and reaction, always acts on two different bodies. Suppose I am applying action on this board, then this board will apply the reaction. I repeat again, both the action and reaction acts on two different bodies. There are so many practical application of third laws. The first application is, students, whenever you fire a gun, when the bullet gets released from the barrel of the gun bounces back. Gun recoil itself. Whenever you fire a gun, the gun recoil itself. Similarly, whenever you jump from a boat, suppose there is a boat and you want to jump out from this boat. Suppose you want to jump out from this boat, then what happens? As you jump out from this boat, the boat starts to move in the backward direction. That means for every action there is an equal and opposite reaction. For every action there is an equal and opposite reaction. And students, remember, our third law also states that, our third law states that the forces always exist in pairs. Third law states that the forces always exist in pairs. Means whenever you apply any type of force, there always exists and another force just opposite to this force. Students, to express the third law, of motion, you can consider a body. Suppose a ball is there, you can consider a body A and another body B. A body A and another body B. These two bodies are colliding with each other or interacted with each other. Suppose the force applied by A on B is F1. Suppose the force applied by A on B is F1 and the force applied by B on A is F2, because these two bodies are in contact. A will apply a force on B and B will also apply a force on A. Then what happens? You will say F1 is equal to F2. These two forces are equal in magnitude, because our third law states that the two forces are, these action and reaction are equal in magnitude. Suppose I am applying a force of 2 Newton on this board, then I will also experience a return force of 2 Newton. Suppose you are hanging yourself on a rope, then if your weight is 20 Newton, then rope will also experience a force of 20 Newton. Similarly, you will write F1 is equal to the F2. Students, since forces are the vector quantities, then to represent vector, we can apply an arrow here. Okay, then we will say F1 is equal to minus F2. Here minus denotes the opposite direction. It states that the two forces are equal and opposite in direction. Action is equal and opposite to the reaction. Then students, remember the third law states that the forces always exist in pairs, and for every action there is equal and opposite reaction. This is our third law, and using our third law and second law, we will discuss one more new topic. But before discussing this topic, let's always remember few basic daily life problems, basic daily life examples to explain this third law, second law. I have taken few examples: recoiling of gun, returning of ball, jumping from the spring. So many examples are there where action reaction concept works. Students, one more important topic is there in all this chapter, that is the conservation of momentum. This is the last topic and most important topic. Then in conservation of momentum, students, we are going to discuss about how momentum remain conserved, because in our previous classes we have completed and we have studied about the momentum, and in our next class we will discuss the conservation of momentum. Thank you students, thank you for watching.